Hi guys, this is Miss Raina coming to you from C347 here at MacArthur High School to talk today about gravitational potential energy. We're also going to do the work potential energy theorem, the work energy theorem a little bit, and the law of conservation of energy. So take out the paper you got in class today. It's got a little picture of a roller coaster, and we're going to get started on that side. Hopefully by now you've got the definition for potential energy. The abbreviation is just PE. All right, so what exactly is gravitational potential energy? Well, it's the energy that happens because of, it's what happens because of gravity. So I'm going to skip the top of there a little bit. Go ahead and write this down in your equation box. When you go higher and higher and higher and higher, you can kind of think of that as building potential, because if you were to drop from that point, you could potentially accelerate to a really fast rate by the time you hit the ground. The higher you go, the more potential you have, the more time you have in the air to accelerate, if indeed you do fall down. So does it take work to change the potential energy of an object? Well, what do you think? If you lift a weight and you change its height, then yeah, it takes some work. You guys can kind of explain to yourself in your own words why or why not in that portion of your notes. So make sure you've got the equation in the equation box, and off we go. Next, the work energy theorem. How does work relate to potential energy? Well, just like it did for kinetic energy, it takes work to get something moving. To increase something's potential energy, you lift it. Definitely takes work to lift something up. So here's the work energy theorem for potential energy. If potential energy depends on the height, right, the force of weight times its height, then the amount of work you put in corresponds directly to how high do you lift it. All right. So just to kind of wrap things up, anytime you gain or lose energy, it's because something somewhere has done work. So the total work done is equal to the total change in energy, and that might be either potential or kinetic. It means look out for the initial and the final situation. So fill this in if you can. If you always have to have an initial and a final situation, then energy can't be created or destroyed. Go ahead and fill in those blanks under letter A under law of conservation of energy. Can potential energy be converted to kinetic? Well, think about it. If I lift something way up high and then I drop it, it sure is going to increase in speed as it falls down. Make sure you write down these equations. If work is change in energy, then we have to take into account kinetic energy, which we already did today in class, and potential energy, which we're doing on the video. This is kind of like the big summary. So yes, it looks ugly and long, but hey, show your parents when you get these problems done, and I promise they're going to give you extra half hour, extra hour on your curfew, extra minutes on your phone. You can ask for whatever you want because you're going to look so smart. All right, so energy can't be created or destroyed. In other words, you trade speed for height. Jump up, and as you're jumping up, you notice you go slower and slower once you hit the top. But you're going slower and slower because you've gained potential energy. As you're falling down, you do get to go faster and faster. So what's going on here? Here's the picture of the roller coaster in your notes. And if the total energy has to remain constant, then if all our energy here is potential, as we lose height, because remember potential is mass times gravity times height, as we lose height, what's happening to your speed? Think about it like you're the one going down the roller coaster. You're going faster and faster and faster. But hey, you lost all your height, so you lost all your potential energy, but it doesn't mean the energy disappeared. Potential energy is 0 at point 2. So what did that change into? Think about that, and in your own words, I want you to describe the conservation of energy in that diagram. So what we have to do now go ahead and write this down in your equation box for law of conservation of energy. And what we've got to do now is save these examples for class. So try them on your own, and we'll do them really quickly in class before we assign problems. All right. Thanks very much, guys, for hanging out with me today through notes about conservation of energy, potential energy, and kinetic energy, and a little bit more about the work energy theorem. Write down any questions you have, try those sample problems on your own, and we'll see you in class tomorrow.